Hey everyone, I'm back again with yet another interesting video. In this one, the problem is three sum closest, and it is on LeetCode. It is a medium type complexity problem. It is slightly different than what we did when we looked at the three sum problem. Although the concept or the loops and all, those things would be almost similar. Just have to that, instead of just looking for an equal match, we are trying to see which one is closest. In many of the test cases, you may not have exact matches as well. So that's the difference here. So let's look at the description real quick. Given an integer array nums of length n and an integer target, find three integers in nums such that the sum is closest to target. Return the sum of the three integers. You may assume that each input would have exactly one solution. So there are subtle differences than when we were looking at the three sum problem. Again, the brute force solution here could be that we do three loops. One is outer loop, and then the other one is for the second integer that we have to sum up with the first one and third one to see whether the distance is any smaller than the previous triplet. And then the third loop is where we are iterating from like the triplet's third element. So yeah, that's the brute force solution. The time complexity of that one would be O(n) cube, and that's what we do not want. We want something better than that. And in similarity to the three sum problem, like I mentioned, the looping in this solution that I'm going to present also is similar. So the time complexity would be O(n) square. So let's get on with the solution for this problem. So what do we want to do? We want to have an array, because what we would be doing is that we have to return the sum of three integers which is closest. But to find out which one is closest, we have to look at the distance of that sum with target and any future triplet sum. So that is why I have created, planning to use this array where the result 0 would be where I'm comparing the distance for the current triplet with previous one, and the first element of this result array would store the actual sum, which we will return back as the output of this particular method. We're going to fill this array with integer max value, because that's what we would use when we are going to compare the the distance of sum of the current triplet with previous one. So that's what we're going to do, and that's why I'm going to fill it with max value, and we will declare some other variables that we will use in the program for our looping. We're going to sort the array, and then we are going to run the loop nums.length I plus plus front is equal to I, back is equal to nums.length minus 1, while now we're doing a 2-pointer loop inside of the for loop. We're going to calculate sum. Let me just add one more variable here, and sum would be the current triplet sum of these loops, nums I plus 1 or I minus 1, and then we are doing front, and then we're doing back. Now what we are interested to compare from one triplet to another is the distance. Now, one tricky thing in this example, this problem is that in the array you could have negative integers. So when you are comparing distance of the current triplet with previous one, we would have to take the absolute value of the distance instead of the non-absolute one, because then we might not be comparing the right distances from the current triplet to the previous one. So result 0 is where we would keep the minimum of the distances as we move along. So here we are going to compare distance, and then we are going to store the distance for next triplets comparison, and this becomes the sum. Like in case if when we have to return something, it will be the result 1, because sum is something that we want to return, because that is the closest to the target. So whichever sum is closest to the target, that's what we want to return, and that is why we have this array which has two elements, 0 and 1. Alrighty, and then it is similar to what we did with our previous problem that we looked at for 3 sum. Where since our array is sorted, we are checking if sum is less than target. That means we gotta move the front pointer by 1, because the array is sorted. We want to go to the next one. Back minus minus if sum is greater than target. That means we have to come to the next smallest element in the array from back. So that's why we are doing back minus minus. If the sum is equal to target, that means we have found a perfect match. It can't get any closer than that. So that means we are done. Break the loop, and we could do something more as well, because it says that there is exactly one solution. So if we have come out of the while loop, we could have a boolean variable, and if that has been set to true, that means we are done. So we can also exit from the for loop. We'll come to that. Let's first get on with without doing that. So alrighty, so we have return result 1. Okay, so I think we should be all good now. Let's run it for this example. Perfect. So -3 was our target, and from this array I think we are getting -1 as one of the sums, and the other sum that we can get from the triplets is 1. So -1 is closer to -3, and that is why the output is -1, which matches to the expected. Let's try submitting it. So submission also works fine. The runtime is 13 milliseconds. Now let's do that small optimization. Boolean flag found is equal to false. Flag found true, and we'll just check it here. If flag found is equal to true, then break. Okay, so alright, I think we just run the test case again to make sure that it does not break anything. It does not. Let's try submitting it. It's hard to say that whether that made a difference or not. But it could make a difference if there are such cases where the arrays are very big and there are multiple triplets that could deliver the same result. Let's try submitting it a couple of times to see if there is really a difference. Yeah, doesn't make a difference. Maybe the test cases are not making the best use of this optimization, but nevertheless this is something that we could do to avoid spending more time once we have found the solution, because the problem says that there is only one solution in it. Perfect. Let me know if you have any questions for me. Thank you.